Hi everyone, and welcome to our video on polynomial end behavior. So a polynomial function is a function that has positive whole number powers on the x's, however many x's there might be. So here's our general form for it. So it looks weird, the general form. The main thing is just really to think if there's positive whole number powers on the x. All the little a things are just coefficients, just regular old numbers. The n is the degree, so that one right there is the degree, and it's always the highest power. So whatever the highest power, whatever the biggest number is for the power is the degree. There's special polynomials. A degree 1 would be linear. A degree 2 is quadratic. And then after that, we just kind of generalize as degree 3 or degree 4 or so on. If they ask for the domain of a polynomial, it's always from negative infinity to infinity. For other vocabulary, we have the a little n, x to the n is the leading term, and that will tell us how the end behavior of the function will work. The a little n by itself is called the leading coefficient, so it's again just going to be a number. The a little 0 there, we call this a naught. Okay, so like a shoelace tied poorly gives you a knot, like that little 0 kind of thing looks like a knot, I guess. That is the y-coordinate of the y-intercept. Okay, so it's found by just plugging in 0 into your function. Okay, because that's how you always find the y-intercept. So it doesn't matter what the function is. It's just letting x equal 0. Okay, so there's a bunch of vocabulary, but the focus for this video is the end behavior. So let's take a look at a way to think of how the end behavior works. Now, there's these devices that might help. So some students like these. I'll show you my general way to find it. But you have, and I don't really even know how to say these. They sound weird, but I guess pe, nel, pol, null. And it's just trying to tell you what's going to happen based on what these values are here. So this is saying if this is a positive, the a little n, so that number, if it's a positive number, and if this is even, then the end behavior goes high and high. So up and up, so high, high. So positive, even, high, high. So that's what that's in words. So positive coefficient, even power means the end behavior goes high and high. All right, where this one, the n would mean negative. So this is negative, even, and then it would go low and then low. All right, so if this is negative here, and if this stays even, then our end behavior is something like that. So the end behavior is only, when we say end behavior, we mean to the far left and to the far right. So we don't really know what's happening too much right in the middle, but we know for sure what's happening to the far left and to the far right. All right, our next one is positive, odd, and then low, high. So positive, odd, low, high. Okay, so that's telling us this one right here is positive this time, and then now it's an odd power. All right, so positive, odd, low would be low to the left, and then high to the right. And then this last one is trying to tell us negative, odd, and then it would be high and then low. Okay, so this is, let me mark that. So that's a negative value. This will be odd. Okay, so that means it will be high first, and then it will go low. Okay, so I'm just putting my little arrows there. Now, the way that, so this is one way that students like, so if you like it, go for it. What I usually do, let me mark it just kind of in this. I usually just use a reference for end behavior. Reference end behavior. Because all it cares about is whether it's positive or negative for the leading coefficient, and then even or odd for the power. So if I have something like this, y equals x, I know that that's just a line. And it would have the end behavior low to the left and high to the right. And this matches, let me mark it in a different color. Let's do purple. This matches my positive coefficient there, because it would be 1. It's a 1 there. It's positive. And then it is an odd power. Okay, so I just try to think of something basic instead of trying to memorize these things. And then similar, let's do it in blue. If it was like y equals x squared, so this is a quadratic. So at this point, we've already seen linear functions and we've seen quadratics. So we often are knowing what's going to happen with them. Well, a quadratic makes this shape. And the end behavior is really just the arrows. And again, it would be, well, this is, my purple's a little messy there, but this is positive in the front, and then this would be even power. Okay, and then from there I can, well, if I know these two, I can get the other two as well. Okay, so that's how I usually just use a reference to find these out. The other way we can do it, okay, so here's our example that we're going to have to match. The other thing we could do is, if we are allowed to use a calculator, I mean, we could plug these in, except it just takes more time. So for instance, let's take a look at these without using a calculator. So it's matching the function with the graph. And so all we really care about are the leading terms. And then possibly we might want to look at our last term. Okay, so let me just underline those in blue, but I'm really bolding the leading term. Okay, so like this first function, let's go ahead and call this number 1. It says f of x equals negative x to the 5th plus 4x to the 4 plus 3x squared minus 8x minus 4. Again, however, this is really all I care about. So let me mark it right here. Also, if I'm thinking all I care about is the leading term, like this, well, then it's very much just like, here's my reference graph. Let me do it in purple. It's very much like, so this I see is negative. This I see is odd. So it's very much like y equals negative x, because that has a negative coefficient and an odd power. And this is a line with a negative slope, so I know that it would do something like that. So it goes high to the left, and then it falls down to the right. Okay, and so based on just that alone, I think we could figure out, based on the options that they gave us, it looks like number 1 matches with this graph. Okay, because all I could see matching in my purple, the up high to the left and the down low to the right. All right, there we go. So there's number 1. Let's see what else we got. All right, so number 2. Let's mark this one as number 2. All right, and then since I'm kind of out of room, let me mark number 2 right here for my reference graph. So the 6. So if I'm looking at just the leading term, again, my reference graph is very much like just y equals x squared, because these both would be positive and an even power. So this is also positive and even. And so if it's positive and even, I know it's a parabola, and it'd be going up to the left and up to the right. Well, with this, we have 2 options. Okay, so we don't want to just choose one blindly. That's where what's underlined in blue can help. This is going to be the y-coordinate of the y-intercept. So for instance, if I do plug in 0 into my x value for this function, we would get 0 plus 0 plus 5. And so we get the point 0, 5. Okay, and based on these 2 y-intercepts that we see, it looks like this one's, I mean, there's no scale to it, but it looks like it's above the x-axis. So it looks like this would be number 2. Okay, so that's where that y-intercept can help. Okay, and then looking at number 3, okay, so a little messy, but here's my number 3. It is y equals, so for just the leading term, is 12x to the 4, which again is like y equals just x squared, because it's also positive and even. And then I already know what this one looks like. It's a parabola again. And there's only one other option there with my parabola. It's got to be this one. So this is the 3rd graph. Okay, so there we go. We could also label it, so I did number 1, 2, 3. So this we could say is f of x, 2 was h of x, 3 is g of x. Okay, just to mark it like that too. Okay, and then by process of elimination, this must be our 4th graph, which is just labeled y. But let's go ahead and also verify why. So it's telling us based on our leading term, so here's number 4 down here, so it would be 3x cubed is our leading term. Well, again, it's just like, it's very much like y equals x, because that is a positive leading coefficient and then an odd power, and y equals x is a line with a slope of 1, so it goes up from left to right, and then so that matches its end behavior right there and there again. Okay, and so we got it. And then also notice on these, let me go ahead and label these y-intercepts at this point in blue. So back to number 3, notice the y-intercept, if I plug 0 in for x, it would have simplified to give us just -9, so that's that point down there. Notice on number 4, if I plug 0 in for x, we would have gotten -2. So it's matching that it's below the x-axis. Yeah, it's not to scale, so if it was on a grid, we could really see it. But for our purpose is just making sure it's either above or below the x-axis. And then the other ones that I didn't mark, so this was number 1. Notice if you plug in 0 to x, it would be 0, 0, 0, 0, and then a -4, so it would be 0 and -4. And then this one, I put the dot, but I didn't label it. That would have been 0 and 5. So notice it's above the x-axis. Okay, so we get those matching as well. Okay, so there's two kind of things that can really help if all we care about to do this as in a quick way is looking at the leading term and the y-intercept. All right, so that's that. So that's how we break these problems down. Okay, so if you do have any questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.